let's switch our orientation up a little bit. Let's start dealing with some y's. So we got a new definition. It's the same definition. It's the same definition. But we're saying that sometimes it might be easier to find the area between two curves by using y's instead of x's. This isn't to make your life harder. This is to, sometimes it's more efficient, a little simpler. So let's check it out. Let's see a problem. Maybe I can go on and on and on and talk about this stuff, but until you see an example, it's usually not the best. So here we go. Used one of the examples from your textbook. Again, like to keep them fairly straightforward for you to be able to go back and check if you want to. So we want to find the area of the region R in the first quadrant bounded by the curves y equals x to the 2/3 and y is equal to x minus 4. So we are looking to find this area here that's trapped in between the curve and the line. Now, we can do this in terms of x's. There's no reason why you couldn't. But what you'd need to do is, well, you'd have to cut this in half. Or, it's not half necessarily, but sorry, not to scale my 4 and my 8. I'm looking at them, they're way off. But we'd have to go from 0 to 4, and then we'd have to go from 4 to 8. There might be a simpler way. We might want to look at it kind of going this way with our y's. So if we could just change these things up, so this is equivalent to x is equal to y plus 4. This is equivalent to x is equal to y to the 3/2 power. You should be able to know how to solve for a variable in terms of the other one. So maybe we can turn these all into y's. So now if you just take your screen and turn it on its side, this is our top function. And this is our bottom function. So the setup's still the same way, except now we're going to go from our y values. We need to, we already have it. It's already set up. It's saying we want to go from 0 to 4 in our bounds. The bounds are no longer in terms of x's. So we're going to go from 0 to 4. And now our top function is actually the function to the right. And our bottom function is the function to the left. So since we just changed it up, we can say it's y plus 4, our top function, minus our bottom function, y to the 3/2 power. Now we're not doing two separate integrals and having to put all the gosh darn numbers together. Either way is valid. I'll never force you into having to do it one way or the other. Well, I kind of will with some tricks. Sine inverse. And then moving forward, let's see if we can't solve this. This isn't so bad. So we're going to say, all right, let's take the antiderivative. We get y squared over 2 plus 4y. Now we got to add 1 to that exponent. We're going to get y to the 5/2 power. And then we're going to divide by 5/2. Just kidding. We'll multiply by its reciprocal. And now we're going to go from 0 to 4. 0 to 4. 0 to 4. 2 squared. So even it doesn't matter. We'll get it. So we're like, all right, 4 squared over 2 plus 4 times 4 minus 2/5 times 4 to the 5/2 minus nothing. Woo! 0, 0. Awesome. So we got 16 divided by 2, that's 8. 4 times 4 is 16. Why the heck did I do that? Oh, it's because the 2's just cancel out. And you're going to get 2 to the 5th, which is 32. And 32 times 2 is 64. All over 5. More fractions. Your life is now fractions. So 32 minus 64 over 5. So what's that? 160 over 5 minus 64 over 5. Oh no. What is that? 96 over 5 units. And it's also good when it ends up being positive. It lets you know you put the top one at the top one, or the bottom one at the bottom one. If you ever end up with a negative, you probably put the top on the bottom and the bottom on the top. But there it is. We have some examples that, sometimes it's easier to use y's. We just have to go the other direction to make sure that your orientation is correct. But that's not too much, I don't think. So it's up to you. We want to be efficient. We want to do the simplest thing possible. We don't want to do the toughest thing possible. But through time, you're probably going to do the tougher thing. Not thinking about it, but you get better. All right. So I think we'll do a little tougher of a problem. And the next one, and then we'll move on to volumes of revolution. See.